All right, so you want to get straight to the important stuff without wading through endless details. That's what we aim for here. Today, we're going to dig into the Qwen3 technical report.
Yeah, this report just dropped May 15th, 2025. It breaks down the newest Qwen large language models.
And our mission really is to pull out the most significant bits, the key innovations, the capabilities of Qwen3, just give you a clear shortcut to understanding this AI. So let's start with the basics. What exactly is Qwen3?
Well, Qwen3 is the latest iteration in the Qwen family. The main goals seem to be boosting performance, making things more efficient, and really expanding the multilingual side.
Okay.
And they've released a whole range of models. I mean, sizes from pretty small 0.6 billion parameters all the way up to 235 billion. And that includes both standard dense models and Mr. of Expert or MOE architectures.
That's quite a spectrum.
Yeah.
What's the big new idea here, the standout innovation?
I think the key thing is this unified framework they've built. It combines what they call a thinking mode for complex reasoning, deep problem solving, and a non-thinking mode for just quick, rapid responses. So one single model can do both, which avoids needing separate models like they might have before.
So instead of switching models, it's integrated. How does that work in practice, this thinking and non-thinking?
It hinges on something called the thinking budget mechanism. This lets you, or the application, decide how much computational power to throw at a task during inference.
Okay, like a slider.
Kind of. For a simple question, you use a small budget, saves compute, gets a fast answer. For something tricky needing real thought, you allocate a bigger budget for better performance. It's about balancing latency and quality.
That makes a lot of sense. You allocate resources based on the need. Smart.
Exactly. And another point they make is about the smaller Qwen3 models. They apparently need fewer resources, but still perform really well.
How do they manage that?
Seems to be through knowledge transfer. The smaller models effectively learn from the bigger ones during development.
Leveraging the giants. Okay. And what kind of performance are we actually talking about?
They're reporting state-of-the-art results on a whole bunch of benchmarks, coding, math, agent tasks, things like that. And they say it's competitive even with much larger MOE models or proprietary systems.
That's quite a claim.
Yeah.
What about the language side? You mentioned multilingual improvements?
Oh, yeah. Huge expansion there. Qwen 2.5 handled about 29 languages. Qwen 3, it's up to 119 languages and dialects.
Wow. 119. That's a massive jump.
It really is. The aim is obviously much broader global reach and understanding.
And are these models locked away, or can people actually use them?
No, that's another key point. They've released all the Qwen 3 models under the Apache 2.0 license. So they're open source, available for research and development.
Good to know. So a versatile, performant, multilingual, and open set of models. Let's step back a bit. What's the bigger picture here? Why develop Qwen 3 now?
Well, the report frames it in the context of the ongoing push towards, AGI, maybe even ASI eventually. They acknowledge the rapid progress from other big models. Lately, GPT-4o, Claude 3.7, Gemini 2.5, Llama 4, their own Qwen 2.5.
Right, the field is moving incredibly fast.
Yeah, it really is. And they note this trend of more top models becoming open source, which they see as fueling innovation. Qwen3 fits right into that, an open-weight model aiming for the top tier of performance.
So riding that wave of open source power.
And they specifically call out their flagship, the Qwen3 235B A22B. It's a MOE model, 235 billion total parameters, but only activates about 22 billion per token. So the idea is high performance, but more efficient inference than a dense model of that size.
Okay, let's dive deeper into the advancements then.
Yeah.
Beyond just having more models, what are those core improvements?
Well, like we touched on, that integration of thinking and non-thinking modes is central. Not needing separate models for different types of tasks that simplifies things a lot for developers, reduces overhead.
Yeah, that seems much more practical.
And the thinking budget feature, that fine-grained control, that's really important for real-world deployment where you're constantly thinking about cost and speed. It allows for that strategic resource use.
Makes sense. You don't want to burn GPUs on a simple lookup.
Exactly. And then there's the pre-training data, 36 trillion tokens. That's just a colossal amount covering all those 119 languages. That huge, diverse data set is really the bedrock for the improved multilingual abilities.
36 trillion. How do you even gather and process that much data? What did the pre-training look like?
Yeah, it was a major step up from Qwen 2.5. They doubled the tokens, tripled the languages, and they also brought in more multimodal data.
Multimodal, meaning not just text.
Right. In this case, they used their previous vision model, Qwen 2.5 VL to pull text out of loads of PDF documents. Plus, they use specialized models, like their math and coder models, to generate synthetic data, basically creating new math problems and code examples to train on.
Okay, so a mix of web text, text from documents, and even AI-generated examples. Interesting.
And the training itself had 3 stages. Stage 1, general, used about 30 trillion tokens just to build broad knowledge across all the languages.
Building the foundation.
Then stage 2, reasoning, focused specifically on STEM, coding, and logic. They used 5 trillion tokens of higher quality data for this and tweaked the learning rate to accelerate improvement in these areas.
So, honing specific skills after the general knowledge base, what was stage 3?
Stage 3 was long context. The goal here was getting the models to handle much longer inputs, up to 32,768 tokens. They used hundreds of billions more tokens for this and employed specific techniques, ROPE frequency increase, yarn, dual chunk attention, things that help the model manage and attend to information over those long spans.
32,000 tokens is a huge context window. How does it keep track?
Those architectural tricks, like dual chunk attention, help it focus. They also mention a big effort in data annotation, developing a system to label over 30 trillion tokens based on things like educational value, safety, etc. This allowed for smarter data filtering and mixing during training.
So quality control and careful curation, not just sheer volume. Okay, let's get to the architecture itself. What are these models actually made of?
Right, so there are the 6 dense models, 0.6b up to 32b parameters, and the 2 MOE models, 30b and 235b.
And the dense ones.
Their architecture is pretty similar to Qwen 2.5. They use established components like grouped query attention, GQA, SWID-GLU activations, ROPE for position encoding, RMS norm for normalization. Standard stuff for efficient performant transformers these days. They did make a couple of tweaks, though, like removing QKV bias and adding something called QK norm, apparently for more stable training.
Okay, refinements on a known base. What about the MOE models? How are they different inside?
Fundamentally, the building blocks are the same, but the key is the mixture of expert setup. They use very fine-grained expert segmentation, 128 total experts, but only 8 are activated per token.
8 out of 128.
Yeah, and they don't use shared experts between layers, which some MOE models do. They also use a specific type of loss function during training global batch load balancing to encourage the different experts to actually specialize.
Trying to ensure the experts really do divide up the work. Makes sense. And how do they handle the text input initially, the tokenizer?
They use their own Qwen tokenizer. It's a byte-level, byte-pair encoding, BPE tokenizer, pretty standard approach, with a vocabulary size of just over 151,000.
Okay, so after all that pre-training, how good are these base models before any instruction tuning?
They ran a lot of evaluations on the base models, checking knowledge, reasoning, math, coding, multilingual stuff, the usual benchmarks.
And what stood out?
Well, first off, the big one. Qwen3 235B A22B base apparently outperforms the previous top open source base models, both dense and MOE, on most benchmarks, and that's often with fewer activated parameters.
So the flagship base model is strong out of the gate. What about the other MOE base model or the dense ones?
The MOE-based models generally hit similar performance to the dense-based models, but crucially using way fewer activated parameters, like around a fifth. They also beat the older Qwen 2.5 MOE models, again with fewer parameters overall. They even mentioned getting comparable performance to the big Qwen 2.5 7.2b dense model, while activating only a tenth of the parameters.
That really drives home the efficiency point of MOE, doesn't it? How did the dense Qwen3 base models stack up?
Overall, the Qwen3 dense base models performed about on par with the Qwen 2.5 base models when you compare similar large sizes, but the Qwen3 model showed noticeable improvements specifically in STEM, coding, and reasoning areas.
So better at the tricky stuff. And the smaller Qwen3 base models, the ones under 32B.
They also performed really well compared to other models of similar size, like Qwen 2.5, Llama 3, Gemma 3 base models, sometimes even better than larger models from those families, especially, again, in STEM and coding.
That's promising for getting capable models running on less powerful hardware. Okay, so that's the base models. What happens next? How do they get tuned for following instructions?
Right, the post-training, they had 2 main aims here. One was tuning that thinking control we talked about, and the other was using the big models to teach the smaller ones what they call strong-to-weak distillation.
Different paths for different models, then. Let's take the big flagship ones first. What's their post-training journey?
It's a four-stage process for them. Stages 1 and 2 are really focused on boosting reasoning. They curate special data sets of complex problems, filter them carefully, and then use reinforcement learning techniques, like GRPO, to improve performance on things like math and logic puzzles.
Sharpening the reasoning skills.
Yeah.
What are stages 3 and 4?
Stage 3 is thinking mode fusion. This is where they integrate the non-thinking rapid responsibility. They use continual supervised fine-tuning, SFT, and design specific chat templates with flags like think and no think to teach the model when to use which mode. This is where the thinking budget concept really comes into play.
Explicitly teaching it to switch gears based on instructions. And the final stage.
Stage 4 is general RL. This is about broad improvements, instruction following, format adherence, safety, agent abilities, making it more stable and useful across the board. They use a complex reward system combining rule-based checks and model-based evaluations.
Sounds very thorough. Now, what about that strong to weak distillation for the smaller guys? How does that work?
That's for the models from 0.6b up to 14b dense and the 30b MOE. It has two phases. First is off-policy distillation, where the smallest student model just learns by imitating the outputs generated by a larger teacher model outputs from both its thinking and non-thinking modes.
Learning by example.
Right. Then comes on-policy distillation. Here, the student model generates its own responses, but then it's fine-tuned by trying to match its internal predictions with those of the teacher model using KL divergence. It's about aligning the student's internal thought process with the teacher's.
So learning not just the final answer, but how the teacher arrived at it. Sounds powerful.
Right.
So after all this tuning, what are the results? How do the final instruction-tuned models perform?
Again, lots of valuation. They tested the instruction-tuned models in both thinking and non-thinking modes across tons of benchmarks relevant to how you'd actually use them.
And the verdict?
The flagship, Qwen3 235B A22B, came out on top among open-source models overall in both modes. It beat other strong models like DeepSeek R1 and B3. They even show it being competitive with some closed-source giants like OpenAI O1 and GPT-4o.
Okay, that's a strong showing for the top model. What about the 32B dense one?
The Qwen3 32B did great too. In thinking mode, it beat their previous reasoning champ, QWQ 32B, and was competitive with OpenAI O3 Mini. In non-thinking mode, it actually surpassed their own larger Qwen 2.572B Instruct.
So punching above its weight class, especially in non-thinking mode. And the smaller distilled models, did the distillation work?
It seems so. The report shows the Qwen 330B A3B MOE model and the 14B dense model outperforming other open-source models that are similar in size or even bigger. This really validates that strong-to-weak approach. And the same pattern held for the even smaller models, 8B, 4B, 1.7B, 0.6B. They also beat larger baselines in both modes.
That's a really compelling evidence for the distillation technique. You mentioned the thinking budget earlier. Did they show how effective that is?
Yep, there's a figure in the report, figure 2. It basically shows that as you increase the thinking budget, performance goes up smoothly across math, coding, and STEM tasks. It confirms you can trade compute for better reasoning performance in a controlled way.
So it works as advertised. What about the efficiency of that distillation process itself?
They included a comparison table, table 21. It suggests that their on-policy distillation method achieved better results in trying to use reinforcement learning directly on the smaller models, and critically, it used way fewer GPU hours. It also seemed to improve reasoning scores, like pass at 64.
Better results with less compute. That's a win-win. And lastly, those final post-training stages, the thinking mode fusion and general RL, what impact did they have?
Table 22 shows improvements after those stages in things like following the thinking on thinking instructions, think follow, handling counterfactual questions, and controlling output length. So better control and general instruction following. They do note a slight trade-off, maybe tiny dips in some very specialized reasoning scores, but the gain was overall versatility.
A reasonable trade-off for a more generally capable model. The appendix also touched on long context and multilingual performance. Anything quick to highlight there?
For long context, Table 23 shows Qwen3 beating Qwen 2.5 in non-thinking mode on the ruler benchmark. Thinking mode saw a slight dip on those tasks, interestingly.
Okay.
And multilingual, well, there are many tables, 24-35, showing it's competitive in specific languages like Spanish, French, etc. And Table 37 looks at the Bell benchmark across 80 languages. Qwen3 performs similarly to Gemma and clearly better than Qwen 2.5.
So holding its own on long context and definitely delivering on the broader language support. Okay, let's try to wrap this up. What are the big takeaways from this deep dive into the Qwen3 report?
I'd say Qwen3 represents a really significant advance. That unified thinking, non-thinking framework combined with the thinking budget offers a new level of flexibility. Then you've got the vastly improved multilingual reach, really strong performance across the board from tiny models to the giant MOE, all underpinned by sophisticated training and distillation techniques.
And the open source nature is key too.
Absolutely. Making these powerful models available really pushes the whole field forward.
Right. So considering how quickly things are moving and the kinds of capabilities Qwen3 brings, especially that dynamic control over reasoning, it really makes you wonder, doesn't it? What kinds of new applications could this unlock? And how might this ability to dial reasoning up or down change how we fundamentally interact with AI systems?
Definitely food for thought.
Indeed. Well, thanks for breaking down that report with us.